Hello everybody, hope all of you are well, and today I'll continue the discussion of this ammonia gas. Okay, in my last class I started the discussions of the chemical properties of this ammonia gas. Today I'll discuss the precipitation of metal hydroxides by ammonium hydroxide solution. So first, if we take the ferrous salt, that is ApSO4, if we add ammonium hydroxide solution, then there will be formation of precipitation of ferrous hydroxide. Okay, plus formation of ammonium sulfate. Now, what is the color of this ferrous hydroxide precipitation? Already I have discussed in analytical part. That is the dirty green precipitate. Dirty green precipitate. If you add excess ammonium hydroxide also, there will be the same precipitation. Next, if we take ferric salt like ferric chloride, if you add the ammonium hydroxide solution, okay, then it will form ferric hydroxide. Plus there will be formation of thrice NH4Cl. Now what will be the color of this precipitate? That is the reddish brown precipitate. Reddish brown precipitate. Okay. If we add excess ammonium hydroxide also, there will be same precipitation. Okay. Then that it becomes insoluble and there will be no dissolution of this precipitation. Okay. Next, if we take the aluminium salt, if we take aluminium chloride, we add ammonium hydroxide, then there will be formation of aluminium hydroxide plus thrice NH4Cl. So we know that aluminium hydroxide is a gelatinous PPT, white gelatinous PPT. So here you have to write white gelatinous PPT. Next, if we take the zinc salt, if we take zinc chloride solution, we add ammonium hydroxide solution, then there will be formation of zinc hydroxide plus twice NH4Cl. Here also zinc hydroxide is white precipitate, okay, gelatinous precipitate. So this is also white gelatinous precipitate. Okay. In this white gelatinous precipitate, if we add excess, then it will be soluble. Okay. Then there will be formation of tetraammonium zinc chloride salt. Okay. That we have already discussed in analytical part. Next, if you take lead salt, that means we are taking that lead nitrate solution, water soluble lead salt. Here if we add the ammonium hydroxide, then there will be formation of lead hydroxide precipitation plus twice NH4Cl. Now in this lead hydroxide, what will be the type of precipitate? White precipitate. This is the white precipitate and it is insoluble if you add excess ammonium hydroxide. Okay, then it is insoluble. Next, we will discuss the chromium salt. We take some chromium chloride and if we add ammonium hydroxide here, then there will be formation of chromium hydroxide and formation of thrice NH4Cl. Now what will be the color of this chromium hydroxide? That is green PPT. Okay. Next, if you take copper sulfate, CuSO4, and if we add ammonium hydroxide, definitely there will be formation of copper hydroxide precipitate plus ammonium sulfate. Okay, and you know that copper hydroxide is a pale blue PPT. If you add excess amount of ammonium hydroxide, definitely there will be formation of deep blue coloration, and that is a tetraamine copper 2 sulfate will be formed. That I have already discussed in analytical part. Okay, so these by this precipitation, by identifying this precipitation, we can also identify the cation. Okay, so these the characteristics color. Okay, and the properties of the precipitate obtained by the action of ammonium hydroxide on metallic salts helps to identify the metallic radical. Okay, this is not the confirmed test, but we can identify. Okay, hence this ammonium hydroxide is an important laboratory reagent used to identify the basic radical in quantitative analysis. Okay. Next, we will discuss the reducing property of ammonia gas. Reducing property. Ammonia is a strong reducing agent, and it reduces certain metal oxide. If you think about that cupric oxide, or if you think about the lead oxides, cupric oxide will react with ammonia, and there will be formation of copper, nitrogen, and water. If you take lead oxide, definitely there will be formation of lead. Okay, that oxygen will be removed, and this is called reduction, and there will be formation of nitrogen and water. Okay. Now, if we write the reaction, then you can understand. So, CuO will react with ammonia gas. Okay, forming copper plus nitrogen plus water. Okay. Now, here you have to balance. If you take thrice Cu plus twice NH3, that will form thrice Cu plus N2 plus there will be formation of thrice H2. Understood? Now, what will be the experimental setup here? That is very important. Sometimes diagram based questions are coming in your board exam. Okay. So here I am drawing the diagram. So first we have to take one fusion tube. This is the fusion tube or the combustion tube. And here we have to take the, suppose we are taking that CuO, and here will be one tube through which the ammonia, dry ammonia gas will enter, passing the dry ammonia gas. And here we have to apply heat by using a Bunsen burner. Okay. Now by this Bunsen burner we are applying heat. Now here this ammonia will react with this CuO, forming nitrogen gas. We have to pass this, we have to cool this nitrogen gas. We have to take one arrangement, that will be the U tube. So here we are taking one U tube arrangement. That will be cooled in a water pump. So here we have taken that cold water, and the water vapor is producing, that will be collected here at the bottom of the U tube. Okay. and the nitrogen gas will go through this pipe and it will be collected by the downward displacement of water. So here is the nitrogen gas. Okay, so in this way we can prepare nitrogen gas. Okay, and here also we can take the lead oxide. So in case of lead oxide, there will be formation of lead, as well as if we pass the dry ammonia gas, definitely there will be formation of N2 gas. So now what will be the observation of this type of experiment or the reaction? That ammonia reduces that black copper to oxide. Actually this CO is black in color. Here copper is in the +2 state. Okay, so this is cupric oxide. So ammonia reduces black copper to oxide to reddish brown copper. And if we take the PbO, that will be the yellowish brown, and it will convert into grey metallic lead. Okay, in case of lead, okay, lead oxide, and definitely there will be formation of a colorless N2 gas that is collected by downward displacement of water. Okay, so hope you can understand. Next we will discuss the reduction of chlorine by this ammonia gas. Reduction of chlorine. In this case there will be two process or two types. In one case we will add or we will use ammonia in excess amount, and in another case we have to use the ammonia in less amount. In two different cases there will be formation of two different compounds. When concentrated solution of ammonia is poured in a jar of chlorine, it burns with a greenish flame, producing dense white fumes of ammonium chloride. So what is the reaction here? First ammonia gas will react with this chlorine gas, and there will be formation of N2 and HCl. Now we have to balance this equation. So here nitrogen is 2, you have to write 2 here. So now it is 6, you have to write 6 here. Then here HCl. And now this 6 HCl, as we have taken ammonia excess, this HCl again react with this ammonia gas, excess ammonia gas, and forming the ammonium chloride. So this 6 HCl will react with 6 ammonia gas, forming that 6 ammonium chloride, dense white film of ammonium chloride. Okay, and finally what will be the total reaction? That is 8 ammonia will react with HCl2. This HCl will cut, forming N2 plus 6 NH4Cl. So here we have taken 8:3 ratio, that means ammonia is excess. So here again I am telling you that observation is very important. Okay, so what will be your observation? Here you have to write that when concentrated solution of ammonia, okay, or ammonia gas is poured, okay, if you take the concentrated solution of ammonia is poured in a jar of chlorine, it burns, okay, with a greenish flame, producing the dense white fume of ammonium chloride. Next we will discuss the case where we will use less amount of ammonia gas and chlorine will be the excess. Okay, So ammonia reacts with excess chlorine, that will form a yellow color liquid, and this yellow liquid is nitrogen trichloride, that is explosive in nature. Okay, so NH3 will react with HCl, forming NCl3, nitrogen trichloride, and there will be formation of NCl3. Okay, is for producing NCl3, and there is formation of thrice HCl. Sorry, it will react with chlorine gas. So NH3 is reacting with chlorine gas. Okay, so forming that NCl3 plus HCl. So here chlorine gas, you have to balance the equation. That is, you have to take thrice Cl2, then it will produce thrice HCl. So this one, that is the nitrogen trichloride. That is the yellow explosive liquid. And here if you see the ratio 1:3, so here we have taken that this chlorine gas excess. So these two reactions are very important for your exam purpose. Next, we discuss that the nitrogen gas can also be prepared from unstable ammonium nitrite, that is NH4NO2. But we know that ammonium nitrite is an explosive, and direct heating will cause explosion. So what to do here? We have to take saturated solution containing equimolecular mixture of or quantities of ammonium chloride and NO2. That mixture, if we apply heat, okay, then first there will be formation of NH4NO2 in the solution, and then by decomposing it we will get the nitrogen gas. So here NH4Cl will react with NaNO2, and that will form that NH4NO2, that is the ammonium nitrite and NaCl. This ammonium nitrite on decomposition forming the nitrogen gas plus water. So in this way also we can prepare nitrogen gas. Okay, so water, NH4NO2, okay, it's correct. So 2 balance is okay. Next we will discuss the test for ammonia gas. In HCl also we have discussed, if you take a glass rod dipped in concentrated hydrochloric acid, and if you take the or brought the glass rod near the ammonia gas jar, okay, it will produce dense white film. The reaction already I have discussed, that is ammonia will react with this HCl gas forming ammonium chloride, dense white film. These are the gaseous state, and we will get the dense white film of ammonium chloride. Next we will discuss the another test. If you pass ammonia gas through copper sulfate solution, ammonia will turn into ammonium hydroxide, so you will get a pale blue precipitate of copper hydroxide. If you pass excess, definitely there will be some deep blue or inky blue type of coloration. Okay, that is the complex salt, that is tetraamine copper sulfate. That complex will be formed. The reaction already I have discussed, okay, in analytical also, and today also I have discussed. And another more important reaction or very important reaction is that when ammonia gas is passed through Nestle reagent. Suppose if we take some paper moisture with this Nestle reagent, it will be colorless. When you will pass the ammonia gas, okay, the Nestle reagent moisture paper, then it will turn brown. Okay, why? Because there is some reaction with this Nestle reagent. What is Nestle reagent? Nestle reagent is an alkaline solution of potassium mercuroiodide, K2HgI4. This is called Nestle reagent. So this K2HgI4 will react, okay, with this ammonia solution in presence of a base. If we can take potassium hydroxide or sodium hydroxide, then there will be formation of one brown precipitate, that is nothing but NH2, HgO and HgI. That is the brown precipitate. Okay. So by Nestle reagent we can confirm the ammonia gas. So in this way we can identify the ammonia gas. Okay. Next and the last we will discuss the use or application of this ammonia gas. In the 75% production of the ammonia are used in the preparation or in the manufacture of fertilizers. We can think about ammonium phosphate, ammonium nitrate, urea. Okay, these are prepared from this ammonia gas. By Oswald process, we can prepare. Generally, nitric acid is prepared by this ammonia gas, and ammonia gas is also used in the manufacture of materials like nylon, artificial seal, dyes, and drugs. Ammonia solution also can be used as a cleansing agent. It can remove oils and grease or disease stains. Okay. Next, ammonia gas can be used in refrigerant. That is in the manufacture of ice. Okay. Why? Because ammonia gas can be easily liquefied, and liquid ammonia is highly volatile and it vaporizes readily and it extracts heat from the surroundings. And another very important point, that is ammonia has a high latent heat of vaporization. That is why this ammonia gas is used in the refrigerant. Now we are using, that is chlorofluorocarbons, that is freons. Okay. So these are, we know that depleting the ozone layer. Okay. So we can use here the ammonia gas for in refrigeration purpose. Now the last point we will discuss, that the different forms of ammonia. Now what is liquid ammonia? You know that ammonia is a gas and it is covalent compound, and if you cool it and apply high pressure, then it will be liquefied. Next one is, what is liquor ammonia? Liquor ammonia is the ammonia gas dissolved in water. Okay. If you take ammonium hydroxide solution, that is nothing but liquor ammonia. Now what is liquor ammonia fortis? Liquor ammonia fortis is the saturated solution of ammonia in water. So saturated ammonium hydroxide solution is called liquor ammonia. So today, up to this, and in this way I have completed the discussion of the ammonia gas, and next two acid remains. One is the study of nitric acid, another is the study of the sulfuric acid. So today up to this, thank you.